Most companies are confident in their data, but few really see the full picture, because the systems that run the business are not the same as the one that explain it. And if you blur that line, things don't just get inefficient, they become unreliable. In this video, we'll break down why this separation exists and what problems it actually solves, and why modern architectures are starting to challenge it. So the question is simple on the surface, but actually quite fundamental. Why did we separate the systems that run the business from the systems that explain the business? And what breaks if we don't? If you go back in time, businesses didn't start with data. They started with instinct. Decisions were made based on experience, intuition, and a kind of tacit understanding of how things work, and that worked up to a point. But as organizations grew, as operations scaled and processes became more complex, intuition stopped being enough, because you simply couldn't feel your way through thousands of transactions and multiple markets, or increasingly interconnected systems. That's where data came in, not to replace the human judgment, but to augment it up to a point, to make decisions more explainable and more consistent and more defensible. And that's a key nuance, because analytics was never meant to replace the human leader or the business leader. It was meant to support the business leader, to provide clarity, to reduce ambiguity, and to bring structure to the decision-making process. And now, alongside that cultural shift, there was also a very concrete technical reality emerging, and the systems that run the business, which is your operational systems, have a very specific job. They need to capture inputs as fast as possible, as reliably as possible. You can think of transactions, you can think of order payments, different events, business events, and these systems are optimized for speed, for consistency, and for availability. The system should be available 24/7. On the other side, the systems that explain the business, the analytical layer, operate very differently. They're not about capturing data in real time. They are about exploring data. They are about aggregation, transformation, sometimes across very large volumes of data. And that's a fundamentally heavier workload. It's computationally expensive. It's not about milliseconds anymore. It's about depth. It's about history, and cross analysis. So naturally, you end up with two different set of requirements. One that prioritizes speed and reliability, and another that prioritizes depth and insight. And trying to force both of them into one system, one very same system, is where things start to break. Now, to understand why this separation became necessary, we need to look at how data is actually stored. At the core of any system, you have databases. They are the physical layer, the component responsible for storing and retrieving information. And traditionally, most operational systems rely on what we call relational databases. So the idea behind relational database is quite elegant. Instead of storing everything in one place, you break data into smaller pieces and more focused tables. And each table represents a homogeneous set of information. So for example, you might have one table for orders, another containing things like date, amount, status of the order. Then you will have separate tables for customers, maybe another one for products, maybe another one for different components of the business. So each of these tables is connected through keys, right? A primary key in one table becomes a foreign key in another, and that's how you establish relationships between pieces of data that are stored separately. So from an operational perspective, this is extremely efficient because it avoids duplication, it keeps data clean, and make writing very efficient, fast, and reliable, right? But here is the trade-off. The moment you want to reconstruct a complete business view, let's say you want to understand a customer order in full detail, you now have to navigate across multiple tables. You are no longer reading data from one place. You're joining you're joining, different, joining it, you're stitching, back together. And that means, multiple lookups and multiple joins, and sometimes across large volumes of data. So even a relatively simple business question, the system might have to traverse several relationships just to produce a single coherent answer. And that's where things become computationally expensive. And that's precisely why, from an analytical standpoint, this model, the relational model, starts to show its limit, because analytics is not about isolated transactions. It's about reconstruction. It's about aggregation and putting things in context, which naturally leads to a different approach. Instead of keeping data fragmented in different tables, you start thinking about centralizing it into one cluster, reorganize the data and optimize it for reading. And that's where the concept of data warehouse comes in. So the idea is actually quite straightforward. Instead of focusing analytical queries to navigate fragmented, highly normalized operational data, you reshape the data ahead of time. You take information from multiple operational systems, you extract it, you clean it, you standardize it, and most importantly, you reorganize it, not for writing, but purely for reading and analysis. In a data warehouse, the ultimate goal is to reduce the amount of work you need to do at a query time. So instead of joining 5 or 6 tables every time you ask a business question, you pre-compute those relationships, you denormalize the data, you align it around business concepts like customers, products, sales, time. You are essentially turning fragmented data into something that is analysis ready, and that changes everything. Because now, when you ask a business question, you're no longer reconstructing, reality on the fly. You're querying a version of reality that has already been prepared, curated, and structured for that exact purpose. That's how you move from raw data that lives in operational systems to reliable insight. This is very important, but this comes with trade-offs. First, we have latency, right? A data warehouse is not real-time by design, right? Because data need to be extracted, transformed, and loaded, and that takes time. So what you gain in consistency and performance, you lose in immediacy. You're often looking at yesterday's data, or data that is, a few hours old. So this is the first trade-off. The second one is complexity shifts upstream. So instead of paying the price at query time, you pay it during data preparation. You need pipelines for transformation to handle data quality checks and governance, and the system becomes more predictable for users but more complex behind the scenes. And the third trade-off that I want to mention here is that you're introducing duplication, because the same data now exists in multiple places in operational systems and in the data warehouse, which means you need to ensure consistency between these systems. You need to manage refresh cycles and handle discrepancies when they appear. So again, it is a trade-off. You're not simplifying the system overall. You're redistributing complexity in a way that better serves analytical needs. And that's really the essence of this separation of both systems. So operational systems are optimized for capturing reality, while data warehouse are optimized for understanding it. So at this point, it's worth clarifiing something. What exactly is data warehouse? Is it a technology, a pattern, an architecture? What is data warehouse? The answer is a bit of all three. In its core, a data warehouse is a conceptual architecture. It is a way of organizing data so it can reliably be analyzed. But to make that concept real, you rely on specific design patterns, and one of the most important ones is dimensional modeling. This is where terms like fact tables and dimensions comes in. Because a fact table is where you store measurable events like sales, like your transactions, quantities, revenues. So it is what happened, right? The dimensions, on the other hand, provide the context, the answer to who, what, where, and when. So the dimension actually gives context to what happened in the fact table. So you might have, a sales fact table connected to a customer dimension, to a product dimension, and to the time dimension. And the connection between them is what allows you to analyze data from different angles. You're no longer just looking at isolated records, you're exploring relationships in structured business-oriented way. And that's the foundation. Now, the next question is it still relevant today? Because with all the talk about AI, real-time data and modern data platforms, you might think that data warehouse are, a thing of the past. They're not. In fact, the principles behind data warehousing is more relevant than ever. What has changed is the technology layer, right? We've moved, from the on-premise systems to cloud-native platforms. Today, data warehouse are built on technologies like Snowflake, Google BigQuery, Amazon Redshift. These platforms remove a lot of the infrastructure burden. They scale automatically, they separate storage from compute and allow you to process massive amount of data more efficiently. But despite all that evolution, the core idea remains the same. You are still transforming in raw fragmented data into structured, reliable insight. And if anything, AI systems depend on that, because AI without well-prepared and well-modeled data is unreliable. You cannot base your decision-making process based on unclean, unanalyzable data. Now, building a data warehouse also implies specific roles and skills. You need data engineers to design and maintain pipelines for extracting, for transforming and loading data. You need data modelers who understand how to structure data around business concepts. You need often, analytics engineers who, sit at the intersection between business and technical layers, refining models for usability. And beyond tools, there is a mindset. You're not just moving data, you're designing a system that represents the business in a coherent, queryable form. So again, it is not just a technology, it is a discipline, and it's still very much alive. Okay, very good. Now I need to go from data warehouse to data lakes, because the next question is, why did we move from structured data warehouses to data lakes? And did flexibility solve more problems than it created? So up to this point, everything sounds quite structured, quite controlled with data warehouses, of course. You take fragmented operational data, you clean it, you model it, and you organize it into a well-defined schemas. And you end up with a data warehouse that delivers reliable, consistent insights. But then something changed. The volume of data started to explode, and not just structured data from transactional systems. You do have log, you do have click streams, you do have sensor data, text, images, data that simply doesn't neatly fit into rows and columns. And at the same time, the pace of the business accelerated, because waiting for data to be fully modeled before using it, it started to feel restrictive. And that's where data lakes enter the picture. The idea was almost to the opposite to a data warehouse, right? The opposite of data warehouse. Instead of, enforcing structure upfront, you store data in its raw, form. You store data in its raw form. You ingest first, and you decide how to use it later. So rather than spending weeks modeling data before it becomes available, you make it accessible immediately, flexible, scalable, and open to a wide variety of use cases. From we're flexible immediately. From a certain perspective, it was a shift from schema on write to schema on read. You're no longer asking how should this data be structured before we store it. You're asking, how do we want to interpret this data when we use it? So this is the shift in the mindset, and that is going to unlock a lot of possibilities, because data scientists, for example, could explore raw data sets without waiting for rigid models, as in data warehouses. New types of data could be integrated without redesigning the entire system. Storage became cheaper and more scalable on the cloud. So on paper, flexibility won. But then comes the real question. Did that flexibility actually solve more problem than it created. Because when you remove structure up front, you're not eliminating complexity, you're deferring it, and sometimes you are amplifying it. So what challenges do we actually encounter when we move to a data lake architecture? The first one is probably the most well known, which is the risk of turning your data lake into a data swamp. When you ingest data without enforcing structure up front, it is very easy to lose control afterwards. You end up with massive volumes of raw data, but if you have no clear documentation, no consistent definitions, and no guarantee of quality, instead of enabling analysis using this data, you're creating confusion. And the second challenge is data quality and trust. In a data warehouse, the data is cleaned and validated before it becomes available. In a data lake, that responsibility is often pushed downstream, which means that every team, every analyst, and every data scientist might be working with slightly different assumptions, different transformations, and potentially different results. And so trust becomes fragmented. And the third point that I want to add here is about performance and complexity, because querying raw and structured or semi-structured data is not trivial. It requires more advanced tooling, more compute, and more expertise. What you gain in flexibility, you pay for in complexity at query time. And then there is governance, right? Who owns the data? Who defines what is correct, and who ensures compliance, security, and access control. In a highly flexible environment, governance becomes harder, but also more critical. So again, it is a trade-off. Data lakes give you flexibility, gives you scalability and openness, but without discipline, they can quickly become unmanageable. And that brings us back to the core theme. You're not removing constraints, you're choosing where to place them. And with that, we've covered the transition from data warehouses to data lakes and the tension between structure and flexibility. If you want to go deeper into how modern architectures try to reconcile both worlds, that's exactly what we'll explore next. Make sure to subscribe and follow to catch the upcoming videos, and thank you for listening.